Lightning is one of the most powerful forces in nature. Lightning can heat the air 4 times more than the surface of the sun. It can travel both downward and upward, and under the right conditions, it can even reach the edge of space. In reality, lightning is just a discharge of electricity, and new studies reveal that nature has a much bigger story to tell. In this video, Omniscient explores the latest discoveries about lightning. Every day, the sun heats Earth's surface unevenly. Land heats up quickly during the day and cools down quickly at night. Water, on the other hand, heats and cools much more slowly. This difference creates temperature imbalances across Earth's surface. Warm ground heats the air above it. That air becomes lighter and starts to rise. As it rises, it carries moisture with it. This rising air is called an updraft. And the stronger the heating, the stronger the updraft. In powerful thunderstorms, these vertical updrafts can exceed 100 km per hour. As the air rises higher, water vapor condenses into tiny droplets. It cools the surrounding air rapidly. Cold air starts to sink downward. This is called a downdraft. All of this happens inside a towering storm cloud, a cumulonimbus cloud. Inside the cloud, due to strong air currents, updrafts and downdrafts keep ice particles moving, colliding again and again. And during these collisions, some ice crystals become positively charged, while heavier hail becomes negatively charged. Over time, the cloud starts to organize itself. It behaves like a giant battery. Positive charges build up to the top, negative charges gather at the bottom. And it doesn't stop there. The negative charge at the base of the cloud pushes electrons away from the ground below. As a result, the ground becomes slightly positive. The separation increases electrical pressure. For a lightning strike to happen, electricity first needs a path to travel. But air is normally an excellent insulator. Nitrogen and oxygen molecules makes up most of our atmosphere, and they tightly hold on to their electrons. This makes air into an invisible shield that blocks electricity from flowing freely. But inside a powerful thundercloud, though the electric field grows so strong, it starts pushing free electrons through the air at incredible speed. These electrons crash into nitrogen and oxygen molecules, knocking loose more electrons and creating a chain reaction called ionization. These fast tiny ionized channels are called streamers. As they grow and connect, they become larger, more powerful pathways called leaders. Then, a network of leaders slowly builds a pathway through the weakly conductive air inside the storm. But here is another surprising fact. The majority of lightning flashes happen entirely inside the thunderstorm itself. These are called inter-cloud lightning or IC lightning. Inside the cloud, electrical charges rapidly move between different regions of opposite charge, creating the flash that illuminates the storm from within. But sometimes, negatively charged step leader moving downward from the cloud. It moves in a series of rapid steps, creating a branching, zigzag pathway through the air. As it gets closer to the ground, the electrical field becomes incredibly strong, and then the ground responds. Tall objects such as trees, buildings, and even the ground itself can send upward moving electrical channels called upward leaders. Multiple upward leaders may form at the same time, all competing to connect with the descending leader, but only one usually succeeds. The moment one upward leader connects with the descending leader, a complete electrical pathway is created between the cloud and the ground. a massive surge of electrical current suddenly rushes through this channel. It creates a cloud-to-ground lightning flash, or CG lightning. This is a type of lightning most people are familiar with. The air inside this narrow plasma channel heats up around 30,000 degrees Celsius, about 5 times hotter than the surface of the sun. This superheated channel and transforms into a glowing state of matter called plasma. But this extreme heat triggers chemical reactions that transform atmospheric nitrogen into reactive compounds. Eventually, rain carries these compounds to the ground, where they act as a natural fertilizer, helping to sustain life on Earth. Then the energy stored in the storm is released. This creates a powerful electrical wave called the return of the stroke that travel upward through the channel from the ground toward the cloud. That is the lightning flash we see. After the first return stroke, the lightning channel can remain partially conductive for a short time. A new electrical pathway called dart leader can then travel rapidly down the same channel. When it reaches the ground, another return stroke occurs. This cycle can repeat several times in a fraction of a second. That is why lightning often appears to flicker or pulse. However, sometimes a dying branch suddenly comes back to life, a quick spark called a recoil leader, reconnecting parts of the channel and helping pathway grow even further. Lightning creates another incredible phenomenon: thunder. When lightning forms, the electrical currents hits the surrounding air into extremely high temperatures. This expands air explosively outward after being repeatedly heated by lightning, which creates powerful shock wave that initially travels faster than the speed of sound. As it moves away from the lightning channel, the shock wave weakens and becomes an ordinary sound wave. That sound spreads outward through the atmosphere. That is what we hear as thunder. Sometimes, lightning travels several kilometers away from the main storm through clear air before finally hitting the ground. These are called bolts from the blue. Some storms don't just flash, they stretch across the sky. A single flashlight can travel over 100 kilometers. These are called mega flashes. And when they strike the ground, they are usually positive lightning. Sometimes, lightning is born in extreme environments, from volcanic eruptions and wildfires. These type of lightnings are called dirty thunderstorms. Lightning travels upward. Tall structures like towers, skyscrapers, and wind turbines can launch lightning into the sky, a phenomenon called upward lightning. Sometimes, powerful lightning can even disturb mesosphere, creating mysterious phenomena such as red sprites, blue jets, and gigantic jets. Around 40 to 50 lightning flashes occur somewhere on Earth every second, producing billions of lightning events every year. Lightning isn't just a flash in the sky. It's a powerful electrical system born from sunlight, shaped by storms, and connecting our planet from the ground all the way to the space. If you find this video valuable, subscribe to our channel. Thank you for watching.